Okay, I'm going to go over really quickly how to do this worksheet, the 3-1-1 worksheet. I'm going to go ahead and share my screen. Okay, and this is the worksheet that you guys have. And this right here, we're looking at sampling distribution and central limit theorem. And we're going to go ahead and start right down here. There's some definitions. Sampling error does not mean that you made an error. And so coming down here, what we're doing is we are calculating the sampling error. Sampling error, we are determining how far off is a sample from a population mean. So we have a population of freshmen, we have a population of sophomores, a population of juniors, a population of seniors, and then we've got a population of all of the entire population. And so we are going to calculate the average population GPA from the freshmen, the sophomores, juniors, and seniors. So in order to do this, first thing that you're going to do, copy this, bring this straight into Excel, and I'm going to do File, New, and I'm going to put it right there. And let's just do it just for freshmen. Control C, I'm going to bring it right down here. We've got the midpoint, freshmen, the number of freshmen, so on and so forth. And if you remember, I'm going to grab this from, what's that called, from the last unit. Remember, this is calculating the probability of a discrete probability distribution. So there we go. And so now we've got this information right here. And in order to get, we actually need to get the probability, Control X, we're going to get the probability of the event, or in other words, the probability of getting a freshman. Okay, and so I'm going to put that right like that, and I'm going to zoom in a bit. So we've got the GPA, then we've got the midpoint, which is the value, if you will, and then we've got the number of observations. And so in order to get the probability of the freshman to get any one of those observations, we're going to do equals 7 divided by 239, and I'm just going to put a dollar sign. Whoops, actually, that's not where I want to put the dollar sign. Equals 7 divided by 239, put the dollar sign right there. So that way, when we drag it down, the 239 does not move. Okay, and so in order to get the average GPA, we're going to do equals sum. So this is the average freshman GPA. Nope, that is not the average freshman GPA. Sorry, that's the probability. That's the sum of the probabilities. We're going to do equals the probability multiplied by the midpoint. Okay, and then just drag it down. Now equals sum. Okay, this is the average. Okay, mean. Now we are going to do equals oops. This should be equals the midpoint minus the mean, so, or the value. Right here we have n, but don't worry about that. It should be the value. And so we're going to put a dollar sign right there. And we're going to drag this down. And then we are going to square it equals. Okay. And then we are going to do equals the probability of the event multiplied by, drag it down, sum. And so this right here is the variance. And then we're going to get the standard deviation by doing equals square root of this. And so now we have the mean, we have the variance, we have the standard deviation for everything in here. And so now we can go through here and you can do the exact same thing for the sophomores, juniors, and seniors. And you'll notice another way to do it is you can do 0.5 multiplied by 0.7, 1.5 multiplied by 14, 2.5 multiplied by 86, 3.5 multiplied by 132, and you add all of that together, divided by 239, the total, and that gives you 2.935, or what I did here also gives you 2.935. And then the next thing that we're going to do is called sampling error. Coming down here, if we have, for instance, we calculated the mean right here. So we take a sample and we subtract the population mean from the sample mean. So you've got the population mean that you calculated right here. So you take the sample mean minus the population mean, that gives you the sampling error. You do the same thing right here with sophomore. You do 2.75 minus sophomore pop mean. That will give you the sampling error. The same thing going all the way down. Okay, and then coming down here, demonstrate the construction of a sampling distribution of the sample mean. A total of 19 students have a GPA between 0 and 1, a random selection of 5. We covered this in class. Sample of 5 random students in no particular order needs to be taken. Of these 19 students, how many different possible arrangements could be made if you select 5 at a time? How many observations were in the population of individuals with the GPA of 0 to 1? So this is literally just asking how many individuals are in that population. Okay, how many data points are there in the sampling distribution of the sample mean? Okay, so if you take every single possible sample of 5 from this population of 19, how many different data points will there be in that sampling distribution? Then the last question is which one has more data points, the population distribution or the sampling distribution? And this does the exact same thing, just with different numbers. Then right here, the central limit theorem, you should be able to determine the central limit theorem. It's in the book. I've got it in my lectures as well. Then if the GPAs were already normally distributed, what size would the samples need to be? And then the GPA significantly negatively skewed. This is also in the lectures talking about, how large does the sample need to be if it's already normally distributed? How large does it need to be in order for you to be able to treat it as normal? And then right down here, the distribution, the size of the sample is related to the sampling distribution. How is it related to the mean of the sampling distribution? How is it related to the standard error? How is it related to the range of the sampling distribution? So that's all that it goes through there. And then coming down here, you've got a random selection of 45 freshmen. It has a mean of 2.835. So what is the sample mean? Well, the sample mean is 2.835. So it's literally 2.835. Okay, what is the population mean? You're going to get the population mean from up here. Population mean, 2.935. 2.935. Okay, sampling error, it's going to be the sample mean minus the population mean. So that's going to be negative 0.1. And then what is the standard deviation? The standard deviation is right here. And then the sample size is right here, 45. And then the standard error. The standard error is the standard deviation divided by the square root of the sample size. And so we're going to come over here and we're going to do equals 0.734 divided by square root of 45. Okay, and so that is going to give us 0.109418. Okay, or really all that you need to do is go to 3. Probability of getting below. So we're going to do equals norm dot s dot dist. So this right here, and then put comma true. This is the probability of getting below this z-score. Okay, so we're going to Control C, paste values, and then let's see, we really only need to go to 3. So I'm going to go, you notice it goes 5, 4, 3, 5. So I'm going to put 5, 4, 4. So the next question is if this observed GPA was an observed score of a single individual instead of a sample, what would the z-score be? A big thing here is instead of dividing it by the standard error, you're just dividing it by the standard deviation. So you're taking the sampling error. Whoops, this right here is the standard error. What did I do here? Yeah, standard error. Why did I do this? Standard error. Now I need to get the z-score. So the z-score, I'm sorry, I'm just losing my mind. It's the sampling error divided by standard error. So sampling error is negative 0.1. Okay, so sampling error. So now we're going to do the z-score. Which is equals the sampling error divided by the standard error. So this is the z-score. Sorry about that. Now I'm going to do equals norm dot s dot dist. And I'm going to do the z-score. And then I'm going to do true. Okay, and so this is the probability of getting below this particular z-score of negative, oops. Paste value 4. So that is the z-score, and the probability of getting below that is roughly 18%. Okay. And then oops. Let's put the z-score. Sorry, the z-score should go right here. And then the probability of getting below that is right there. So if the observed GPA was an observed score of a single, so the big difference here is for this z-score, instead of dividing it by the standard error, you're actually going to divide it by the standard deviation. Okay. And so we're going to put the standard deviation right there. And we're going to put the sampling error right there. And we're going to do equals sampling error divided by standard deviation, which is going to give us a z-score of negative 0.136. So I'm going to copy this, paste. Okay, negative 1.36. And the probability of getting another individual observation that's that extreme or more extreme is going to be equals norm.s.dist. We're going to put the z-score true. Okay, and there's a 44% chance. Let's do, yep, 0.446, 44.6% chance of getting a value below this z-score. So the reason why, so this is the probability of getting below an individual observation. This is the probability of getting below, getting a sample of 45 with a mean of 2.853 or 2.835 or lower. So the reason why the probability of getting a sample is less extreme than an individual observation is because getting one, like there's almost a 50% chance of getting this. And so it's like, it's not it's not significant at all. It's not, unique. But getting 45 observations with that average is much more unique. And so that's why the probability of getting a 45 with an average of 2.85, 2.835, the larger and larger the sample size gets, the closer and closer it gets to the actual population mean. And so if you've got a sample of 45 and it's still 0.1 below the population mean, that's not as likely as taking one single observation and having it 0.1 below the population mean. So that's why it is right there, and I explained that a little bit more. Then coming down here, we do the same exact thing over and over and over again. Then also right here, you can do put the standard deviations right here and the standard errors right here. And you'll notice that they're slightly different with the way that you go about doing that. Yeah, that's pretty much this worksheet. So hopefully go ahead and work through that. The entire quiz is pretty much over this worksheet, and the Excel workbook is something that you're going to turn in for a group grade at the conclusion of the unit. So yeah.